Hello. Okay, so I'm trying to do a demonstration of an example using an example for question 4 on homework 1. And the question is asking you to plot a let me get it straight. The question asks you to compare a standard normal to a logistic distribution, and they give you the CDF. Okay, so the task over there is, first of all, you need to know how to plot a standard normal. Second of all is how you can transfer this CDF of logistic into its PDF and then plot it. So I won't tell you exactly what you should do, but I want to give you, especially those people who have very little experience with R, I want to give you an example of, say, now, instead of doing normal and logistic, I will do an example with normal and t-distribution, and then show you how you can do that. Okay. So, so have a look here. So this is my demo over here. I posted some Moodle as well. It's called Homework 1, Question 4 Demo. So now, so for here, let's try to use d norm and dt function. So both of these are evaluating the density. So the way that you can get this to work is, first of all, I'm going to initialize boundary values. So here I'm choosing -10 to +10 and increment by 0.1. So you're having 2,000 points incrementing from -10 to +10 by 0.1. Okay, 2,000 points over here. Oh, sorry, 200 points. I'm sorry, 200 points. And then if you try to use the dnorm function, so first of all, dnorm is built in. So if you want to know how to use the dnorm, type $dnorm, and then you will see that the help file on the right-hand side is going to tell you what you're doing with this particular function. Okay, so dnorm is trying to evaluate the density, PDF in particular, of the normal distribution. So what you do is, so over here you see that I have dnorm, and then all of the numbers from -10 to +10, and then I'll evaluate for the standard normal what is the PDF for all of those numbers, small numbers. Okay, so you see that I actually put all of the code together in just one line. So I'm plotting the dnorm of these 200 values, and then I specify like the title of the graph, etc., etc. So you will see that later. So now I run it, and you see that I have this red dot telling me what is the PDF of the standard normal. And now let me do a demo of overlaying, plotting this t-distribution with degrees of freedom 2. So dt, just from the name you probably would guess, is the PDF of the t-distribution. But you know that t-distribution has one parameter, is degrees of freedom. So you need to tell R what is degrees of freedom you're looking at. I'm just playing with it. I'm just putting 2 down here, and I'm using blue for the color. And I'm so instead of plot, I'm using points over here. And that is how you can put one graph on top of each other, so you can have 2 plots in the same graph. Okay? So if I run this, okay, you see that my t distribution in the blue color is showing over there. And lastly, I do a legend, and that tells us, like just for readers in particular, what are the colors for, like, because you have 2 different plots, and blue is for the t, and the red is for the normal. Okay, so right, so this is how you can do the plot. The question itself is asking you, so first of all, so 2 parts pretty much. First of all, you need to plot the normal and the logistic, and the second part is asking you, suppose you draw 1,000 draws. Okay, it's not that, so you notice that here we're not using the random draw functions at all. You can just use the D, stands for density, getting the PDF. You can still tell some story based on the graph. So for example, between the normal and the t over here, that you can see over here. So t distribution, we know that it's very similar to the normal. It's symmetric, bell-shaped, center at 0. The only parameter for t is the degrees of freedom. And we know that as the degrees of freedom increases, the t distribution is going to approximate the normal. Okay, so now degrees of freedom is only 2. And in general, t distribution is feather tail. like shorter in the height comparing to the normal, as you can see in the graph, and then fatter tail, meaning that if you're looking at the standard normal and compare that to the t-distribution with degrees of freedom 2, if you try to answer the second part of the question, you will say that the t-distribution is going to have more extreme values because it has fatter tails. So for example, if you look at, if I cut at 50, for example, here, or maybe like 70 over here, and you see that at the 70 point, the index is 70, there are more, like the density of the t-distribution is higher, right? Meaning that there will be more extreme values of the t-distribution with degrees of freedom 2 comparing to the normal. Okay? All right, so this is the demo for comparing standard normal and t-distribution or degrees of freedom 2. Please go back and check what you can do with the logistic regression. Oh, sorry, not logistic regression, logistic distribution. And the hint over there is what you're given is the CDF. You should try to take derivative to get the PDF and then use that as what you can fit in. But also something else you might want to use is, so you might guess, we have d norm dt, do we have d logis? Yeah, so you can check that. So whichever way you pick will be fine as long as you can do the work. Okay. All right. That's all. And okay, good luck.